Thanks a lot, Christian. And first of all, a huge thanks for you and your team to organize this a great webinar series. I think it has established as an important landmark in communication on biochar. So thanks for having me here. And I will give today a quick summary on the findings of the European Biochar Market Report 2023-2024. As many of you might know, we've been doing this now the fourth time. And yeah, let me jump into it. And before I go there, just a very quick summary. Who is EBI? We are a European, or we are the European industry organization with now 106 or 7 members. And we're working on mainly 4 topics. One is policy, the second is market intelligence, the third one is communication, and the fourth is industry standards. Main focus today, of course, is market intelligence and the European market data, but I would like to quickly give a bit of a framing on what we do and what we find important, and therefore I put a couple of slides before. The first one is on the CRCF. I guess most of you know and have heard about this, but this cannot be said how important it is. The European Commission is currently in the process of setting up the carbon removal certification framework that will rule all CDR activities. And it was extremely important for biochar to be accepted as permanent carbon removal. And that actually happened after a huge initiative from basically all the European CDR stakeholders to make this CRCF system technology neutral, and it is, and biochar is accepted in the bucket of permanent industrial removal as well. And talking about permanence, there was also a very exciting topic during, I would say, in the last 12 months. And we wrote a report on this, which you can download on this link. You will see. And so we deeply looked into the topic of permanence of biochar based on 2 January 2024 publications from Sani and Asi et al. Sani et al. And Asi et al. With a review board to have a stakeholder process, which was very, very exciting process, because there was also controversial discussions about permanence. But as a conclusion of that report, so read the whole report, it's very exciting. But as a conclusion of that report, we can say that inertinite biochar fractions, so the fractions that are highly carbonized, they will not relevantly degrade in soils, even within climate relevant periods. So that is an exciting piece of information about biochar. Another topic which I would just briefly touch here is BCR's role in net zero pathways. And you will find this in the full market report in much more detail, but I'd like to highlight it a bit because it's so important for economics of biochar. So if you look at biochar, I mean, I don't have to explain this one, and I don't have to explain that you can make renewable power from biochar. In any case, there is renewable heat, renewable power is optional, and there is biochar, and that can either be used in the metallurgic industry or in carbon removal. And the exciting thing of biochar from among the carbon removal technologies is whatever the output of the pyrolysis machine is, it pays in either on the upper side of the axis or on the lower side. So it's either carbon removal or it's emission reduction, and we need both. Carbon removal is senseless if we don't achieve our targets on the emission reduction side. And so, and let me already put here in the report all the numbers that I'm reporting here about the European the biochar market is only related to the carbon removal element. So any biochar that is produced for the metallurgic industry is not included in the numbers I present on the biochar numbers, which is an important thing to mention. And in the full market report, we're going to show there's an inherent correlation between energy and carbon removal. And that's a complicated system because we have electricity and heat, and they come with a carbon footprint. And this changes over time. So it's really relatively complicated. But what this results in is that when we look at carbon removal technologies, it's not enough just to look at the carbon removal element. We have to look at the energy side as well. And I've just brought one of the slides we've shown in the market report that shows there are energy co-benefits or disadvantages to different technologies. If you have pyrolysis and you use the heat, which is recommendable or necessary, you get an additional benefit in terms of effect. So what we look here, that slide here, that shows you the net CO2 effect per ton of CO2 captured. And that's a very important metric. So if you are interested in these kind of considerations, look at the report. We're also working with Fraunhofer on going deeper. And the basic result of that is biochar carbon removal is a no regret solution, irrespective of how well advanced the carbon removal, the emission reduction is. Now, let's come to the real topic of the market report, market intelligence, the market report, and I'll skip motivation and methodology because many of you know that and can read it in the full report, and we'll focus quickly on manufacturing equipment. Then the main topic will be the biochar market, and then I'll quickly talk about scaling. Now, and I don't want to forget to say thanks to the sponsors of this report who finance the creation of this report, which is Carbon Removal Partners, Carbon Drawdown Initiative, two investors in the carbon removal space, and Carbon Future, the leading MRV system. Now, first to the equipment manufacturers. And I've only brought one slide out of, I think it's 6, 7, or 8 slides that you find in the full report, because it's really amazing. We have in Europe over 30 technology providers. Many of them are at TRL 8 or even TRL 9, which means these are serial produced systems. There are now several suppliers where you just can order. You don't have to be brave. You just need to order a system and you will get it, and it will go in operation as scheduled. So look at the full report, and then you will see the full variety of European equipment suppliers. In terms of numbers, from in 2023, we had a net increase of 41 production plants. It was 48 systems have been installed. I'm only counting systems above 250 tons production capacity, tons of biochar production capacity. 48 systems were installed and commissioned, but there were 4 relocated plants. So in order to avoid double counting, these are obviously deducted, and 3 were permanently decommissioned. And so we have a net increase of 41 production plants. For 2024, and it was larger. In our projection last year was a bit higher. It was 51. That was mainly due to the shift of some of the projects they slipped to 2024. And but that's a very high rate, I would say, and that has to do with I'm not. If somebody tells me he will install a system this year, And I don't really believe it. I will rather push it into the next year in my projection. And this is also then now true for 2024. I have 54 projects in the databases that are marked to be commissioned in 2024. And that means from the 171 plants that are operational, that were operational end of last year, we expect that to grow to roughly 220 systems by the end of this year. What is also new and surprised me a bit, there are many further projects, large projects in very much advanced permitting process that will be commissioned in 2025. I have already 40 systems in the databases where they are really very much advanced. Now, to the numbers in terms of production capacity, and this is production capacity. By end of 2023, the capacity was 75,000 tons. Once again, does not include biochar that is not dedicated to go into carbon preserving applications. And this capacity is expected to grow to 115,000 tons by end of this year. Now, growth rates, and my background is solar energy, and we always looked at the growth rates because that really shows you the real dynamics in the market. So we saw a growth rate of 41% from 2022 to 2023. We saw an average growth rate of 54% over the last 3 years. And based on the project pipeline, we expect the 2024 growth rate to be at 55%. That's a typo. I just realized that. Now, this was production capacity. To assess the actual production, I make assumptions, and that is that in the commissioning year, I assume to have 6 months of operation flat. I make the same assumption for all of the plants. That's a good mix. And I say 6 months of operation with 60% uptime and 12 months of operation with 80% uptime in the following years. This is an assumption. And based on these assumptions, I get to 49,000 tons of biochar production in 2023, equivalent to 130,000 tons of CO2 and 70,000 tons of production in 2024, equivalent to 200,000 tons. So we really see we're starting to become relevant in terms of carbon removal in the CDR space. Obviously not generally. Interesting also, we see more countries coming in. I mean, the classical regions, Sweden, Denmark, Finland, in the Nordics, as well as Germany, Austria, Switzerland. These are the main countries, but we also see new countries coming in. Spain, France, UK is becoming active. So market trends beyond the general growth. And I've collected here a couple of main findings. The first one is that the CO2 certificates are just an indispensable element of the whole business cases. It's very difficult, up to impossible, to show a business case without monetizing or valuing the carbon removal element to it. The second thing is market prices for the pure biochar have come under pressure because the rapidly increasing production volumes make it a challenge to find fast enough the applications. But it's growing. The markets where we expect the strongest growth is biochar in concrete and in urban soils on the carbon removal side. And we will see that, or I expect that the metallurgic industry might work as a buffer in the market if the carbon removal markets can't take up the volume fast enough. And well, 2 more points is that we see still new industrial players entering the market, and we see some of them are very experienced engineering companies. And we also see that agricultural residues are becoming increasingly important. And last point on this one, valorization of surplus energy is, I think it's impossible to make, or very, very difficult to make business cases that fly without valorization of the energy produced. And I'll go very briefly through the reference projects or through a selection of the reference projects shown in the full report. That's a project with a pyrox machine from Novocarbo, 1,700 tons of biochar. And I always show the energy production here. It's producing energy and heat, electricity and heat, and the heat goes to the district heating network. That one is also an exciting project producing or drying sewage sludge. It's a drying service for sewage sludge and producing biochar. This one here produces electricity, substantial amount of electricity and heat for the company's heat distribution network, and 1,000 tons of biochar with Syncraft as an equipment manufacturer. The previous one was with NGE as an equipment manufacturer. And then we have one more system from Wow Green Metals using demolition wood, also feeding heat into the district heating network. Most of the biochar will go into the fossil industry. So this number is not counted into it, but I wanted to show it because it's getting an important element in the biochar business. And last project here in this list is a project from Stistal that is currently in commissioning, and the feedstock here is biogas digestate, and the heat will be used to upgrade biogas. And it's quite substantial in size, 15,000 tons of biochar being produced here. So let's look into the future. Where can this whole thing develop to? These are the same numbers you saw before on the bio. Now this is not anymore biochar. It's converted by a factor of 2.8 to CO2. And we're gonna see what happens if we can continue to scale or to keep the 50% growth rate up until 2030. If we can do this, we'll end up at 2.3 million tons in Europe alone on BCR, and that is just under 50% of the ambition of the European Commission for permanent technical carbon removal. So it's quite relevant in Europe. And again, these are European numbers. Now, let's go one step further from 2030 to 2040. Here down, you can see again the 2.3 million tons in 2030. And you can see an escalation scenario in exponential growth. At one point in time, growth rates will go down. That happened in solar, that happens in other fast-growing markets. And we modeled a growth scenario with 40% up until 2035 and 30% until 2040. And this would bring us to roughly 50 million tons by 2040. If we would assume a slightly more aggressive growth rate or an upside scenario, which would mean more political support, more investments in the technology, with slightly higher growth rates, this would bring us to 80 million tons. Now let's compare these 50 to 80 million tons to the European ambition. So first of all, if we reduce in Europe the emissions by 90%, which is exactly the target, by 2040, the remaining emissions will be 490 million tons. That's the remaining emissions of the European Commission according to the plans, 490 million tons. The European Commission targets an overall volume of 400 million tons of carbon removal, out of which 75 million tons are dedicated to technical permanent carbon removal. So the answer to the question, can we become climate relevant? Yes, I think it's very clear. I'm pretty convinced that we can achieve these growth rates. For sure, they will not be limited by the availability of biomass in such a scenario. And looking at the 490 million tons, respectively, the 400 million tons and the 75 million tons, we can clearly achieve the target to become climate relevant. So the answer is yes, BCR is capable of delivering carbon removal at climate relevant volumes within 15 years. So if you got excited by the presentation, by the data, you will find much more data in the full report, which you can find on the website of EBI or by clicking on the head here, and you can download the full report. Thanks a lot.
Thank you very much, Hans-Jörg. Very exciting indeed. So I have one first question is, uh, do you also know the average planning period so for a pyrolysis plant right now? Are we talking
Um,
about several years or?
Yeah, it really depends. I mean, that in a way it changed because also the size of the systems was growing. While it was around 3 to 4 years ago, that was the average size of a system. Today, the average size grew to 570 or even 600 tons now. And I can give you one example, the one which I also showed in the reference projects, the plant that is operated by Salzwerke, a German salt company, a Synkraft plant, where Carbona is taking the biochar. I did the pre-project development for this project, so I know it well. It took us 6 months to get it to financial decision of the board, which I think is very fast, which showed that Salzwerke is quite agile. And then it took almost exactly 1 year to get it into commissioning, which is very fast.
Yeah, that's surprisingly
But
fast.
what I said, when we look at projects that are 5,000 tons of biochar, these have typically long lead times. So it's in a way anything between, I would say, between 1 year and 3 years, depending on size and locations. And there are also projects that were held up in permitting by very stupid things. I know one project that was delayed in commissioning because, and it's not a joke, because the toilet didn't comply with German rules.
That sounds like Germany, yes.
Yes.
Uh, so you got a question in the chat. For the showcase projects, do you have data on yields achieved? So tons of feedstock to biochar tons produced. The background of the question, if in the EU the direction is front-end gasification followed by pyrolysis, um, and low H2C ratio, this would for high rate of producer gas production. In the US, the focus is more on higher biochar yields. So
Yeah, I mean that is totally technology dependent. It's not much project dependent. It's really technology dependent. And obviously, when you have a gasification system, the main output is energy, and then you can be as low as 15% of the carbon will be converted into biochar. But once again, this is why this is not bad. This does not mean this is bad because you're paying in. This is why I showed this slide. We're paying in on the emission reduction side, which is as important or even more important than the carbon removal. The projects that and this depends on the individual project. What system makes more sense? If biomass is inexpensive and energy is not too valuable, I would recommend a system that has the highest possible conversion rate that can be up to close to 50% realistic.
and I think maybe you're lost. I'm not sure. If you're lost, then I would say, no, yeah,
Okay.
a quick last question, just a short answer. Do you see any particular pathway going down energy or high biochar yields in Europe?
No, we see both types of extremes very much there, but we clearly see in Europe. I would say it's impossible, and I think it's good that it's impossible to realize a project without decent energy yield. This is you need to be paid. You need to decently have to set up a smart a smart setup for using energy and get paid for it.